Hello everybody, and welcome back. Welcome back. Question number 19 is what we're looking at right now on the 2003 Grade 8 level Gauss contest. Okay, so let's grab our pen, put on our thinking caps, and take a look at question number 19. In the diagram, ABCD is a rectangle, and three circles are positioned as shown, so it looks like they're just touching. Okay. And they touch the tops, and they touch the sides, and you touch each of them. Okay. The area of the shaded region, rounded to the nearest centimeter. So already I'm thinking I'm probably going to need my calculator for this one. Rounded to the nearest centimeter is usually, it's a messy calculation sort of thing. Rounded to the nearest centimeter is, and then we have some possibilities here. All of them hovering around the 40s. Okay. So, what can we do here? Well, these come up a fair bit on Waterloo math contests, and it's area of a shaded region style question. When I do an area of the shaded region question, I start thinking basic shapes in my head. So things like circles, we have some circles, rectangles, triangles, right angle triangles are really good, half circles, quarter circles, things like that. And I start thinking of formulas for them. But I also start thinking, how can I realize the shaded region as a sum or difference of a combination of these basic shapes? Because the shaded region in the question, there isn't a formula that you should know for it. You sort of have to come up with your own way of figuring it out. And I noticed that it's a rectangle. It's the area of the whole rectangle with the area of each of these circles cut out. So if I can figure out the area of this whole rectangle, and then figure out the area of each of the three circles, then I should be able to take the area of the rectangle, subtract off the three circles, and what's left will be the area that they've shaded in. Okay? So it's always good to have an attack plan to start thinking, how can I realize this weird shaded region as a sum or a difference of more basic shapes? Sometimes it means, drawing in a line and making a pentagon into a rectangle and a triangle, or cutting things up into a whole bunch of triangles, things like that. But that's generally how all these questions should start off, is recognizing the shaded region as a sum or a difference of areas that you can find. Okay, so we'll draw ourselves our little picture. We're not given a whole lot of information. For example, we don't know anything about this rectangle other than it has a length of 24. I don't even know the height yet. One circle. I'm going to try and make these circles touch, but it's not really the point. So I usually start off by saying something like shaded region is the rectangle minus these three circles. Okay? It should be clear that all these circles are the same, because if we take the little time to mark it up, whatever this length here is, it's going to be the diameter of each of these circles. So each circle has the same diameter. And you split it in half, each circle has the same radius. Okay, now I'm singling out the radius and giving it a name rather than the diameter, because I'm thinking ahead. I'm saying, all right, if I'm talking about the difference between a rectangle's area, I need base and height, or length and width, and multiply those two together. And then subtracting off circle areas, I only know one formula for the area of a circle, and that's pi r squared. So I need the radius rather than, say, the diameter or the circumference or anything like that. So that's why I've taken the time to say r here is going to be the radius, and that's going to help me in my calculations. Okay. So I know that once I figure out r, I'll be able to work out the area of the rectangle, because it's going to be 24 times 2r, and I'll be able to figure out the area of each of these circles, which I now realize are in fact identical. So it'll be 24 times 2, so it'll be 48r minus 3 pi r squared. I just need to figure out what r is. Okay. Now you'll notice in the picture, my picture's not as good as theirs, but In the picture, each of the circles are touching, and they're touching the sides of the rectangle. And so this is called a point of tangency. Anytime you have a line that just touches the edge of the circle, if you connect that point, the point of contact, with the center of the circle, you'll get a right angle. Same thing here in the insides, although it's not a nicer concept there. But if I write these in, I can notice pretty quickly that 24 is 1, 2, 3, 4, 5, 6, r. So divide by 6 on both sides, I get r is equal to 4. Okay, well that's all I need for the shaded region. I just finished explaining. All we need is r, because it's going to be the rectangle, which is 24 times 2r, minus 3 copies of this circle, which is 3 pi r squared. But what's r? Why, it's 4. So we get 24 times 2r, that's 8, minus 3 pi, and then we have r squared, so that'll be 4 squared, so that'll be 16. So 24 times 8, that's going to be some number. I'm trying to think of it in my head right now. I want to say 112. No, that's not right. Oh, no, it is right. I'm actually going to split it up and say 48 times 4 minus 3 times 16 is 48, and that's the reason I'm doing that. Just because I'm trying to do this without grabbing my calculator as much as I can. So we got 48 times 4 minus pi. Okay. Or you could have just grabbed your calculator and said, well, 24 times 8, it's 192. Oh, 2 times 8 isn't 8, it's 16. Anyway, so you could add 192 minus 48 pi. And that would have been fine. You grab your calculator, you're all set. Or what I'm going to do here is I'm going to try and calculate this out anyway. So it's an interesting exercise to see whether or not you can. I'm going to use 3.14 for my approximation for pi. They're only asking to the nearest centimeter. So I'll see what I can do here. So 6, that becomes a 9, 8, and that's a 0. So 0.86 times 48. We get 0, 0. 6 times 8 is 48. Carry the 4. 8 times 8 is 64, so that should be 68. And then 4 times 6 is 24. And carry the 2. 4 times 8 is 34. Sorry, with the 2 added. So 0, 0, 8, 2, 1. So we get a 1 there. Carry a 1. It'll be 41.28, I think, is our answer. So I would go with an answer of A. Now let's just double check and see what the calculator says. Okay, so I'll do 24 times 8 minus 48 times pi. And I get 41.20, 3, 4, 5, 5, etc. Not bad. Both of us agree. So if you did happen to forget your calculator, that's all right. But I do encourage you, especially for questions like this where they're asking you to round, it's a great idea to grab a calculator and have that nice decimal display. So I think if you are going to forget any tools, make sure that it's not the calculator you forget. I do remember there was one math contest. It was just a short little half-hour 6-question one. But I do remember having to go all the way back up to the drama department where I had been before the math contest, just to get my calculator out of my bag, just because I had forgotten it, and I felt really bad because I was wasting time on the test. So try your best not to do that. Okay, calculators. We try and avoid them because it's more about the mental math and the thinking. But sometimes, especially with a question like this, you just need it. So I encourage you to remember your calculator. Okay, so that's question number 19, the penultimate question in section B. And so we're going to take a look at the ultimate question, question number 20, and that'll finish off section B on the 2003 Gauss. So I'll see you guys in the next video for question 20.